The Second World War concluded with a decisive blow against the Japanese Empire, as the land of the rising sun was brought to dusk beneath an artificial recreation of solar power. In the years that followed, the world entered a new and uneasy age. The Soviet Union's successful test of a nuclear device in 1949 shattered the American monopoly on atomic power. Europe, devastated yet strategically vital, found itself divided, its eastern half drawn into the Soviet sphere, its western nations increasingly dependent on American protection. Caught between two global superpowers, each capable of unprecedented destruction, Western Europe faced a stark choice: submission to external influence or self-determination through unity. Economic integration became the first step towards this goal. Increased cooperation and technological exchange among European partners culminated in the formation of the European Coal and Steel Community in late 1949, binding the industrial foundations of former rivals together to make a future conflict not only unthinkable but impractical. However, beneath this public economic framework, a less than secret but still unofficial military defense alliance was included in the treaty, in which members pledged to combine their efforts in weapons, nuclear and space technologies, forming the European Space Research Organization under majority French, West German and British administration, with the main goal of developing a medium-range ballistic missile for the still in development British nuclear program. Now, in 1951, Europe stands on the threshold of that ambition. Preparations are underway to test the first ballistic missile designed and built within its continent with nuclear capability in mind. In the nature of cooperation, it is powered by a French engine, with a fuselage manufactured in the United Kingdom, and avionics produced in West Germany. Hopefully, the fledgling weapons program can be used for scientific and peaceful endeavors in the future. However, what is clear is that the European spring has arrived. And with that, welcome to my KSP-RP1 Career playthrough. We are doing a European run, which means I will be limiting myself to parts used by European space programs, and if absolutely needed, I will allow myself to use some American parts. We are in the year of 1951 and are still witnessing Hermes 1, the first launch of ESRO, which you may have seen in the intro. And I do have to say it myself, this little sounding rocket is looking rather well, and I am very proud of my design for this very first launch. It has performed surprisingly well too, with all those contracts being completed, giving our space program the money it desperately needs. Sadly, looking at the apparatus, we have not reached space yet, but science is still nevertheless being transmitted back to our mission control. Now, plummeting down to Earth, thankfully not armed with any payloads except for simple scientific ones, we are entering their atmosphere rather quickly, as we can see, and to prevent any damage, we self-destruct the missile before it hits the ground or any unfortunate engineer. This being the first official look at the Space Center in French Guiana, I'd like to thank Carnasa for constructing these beautiful buildings and the beardy penguin for being an inspiration to the series and putting together the For All Kerbalkind mod pack. Now we need to spend the first, but hopefully not the last science points into post-war rocketry, early tracking systems, early rocketry, and early solid rocket engines. Concluding our science shopping, it is time to buy upgrades for the VAB and R&D, putting 3 points into VAB and 4 into R&D, drastically increasing the research speed for the technologies we had just unlocked. But now, I have to admit that I'm a fraud. In case it might not have been obvious, I had already launched a Hermes rocket in the safe. Sadly, OBS crashed while recording and I had realized too late. That is why I had already researched post-war material science and was now at 50% completion. Hopefully the rest of the series goes without incident. Something I had also forgotten to say earlier was that I will not be rewinding any launches that failed due to human error, engine explosions, or other related mechanical issues. However, if I am suffering a Kraken attack or anything else, I might consider rewinding the launch, at least for that one. Having now said that, we are again on the launchpad for our official second Hermes launch, marked by the number on the hull. This time we have picked up a contract to fly 125 units of sounding rocket payload with us to a height of at least 80 kilometers, which our Hermes can do quite easily. The launch is sped up a bit, as it is mostly the same as our previous one. In the future, not all sounding rocket launches will be covered in this much detail. Actually, different from the early launch, we can see the engine burning out after using all its propellant. We can now see Hermes O2 has crushed the required height in an upwards of 113 kilometers, delivering the redacted payload into a very thin atmosphere, completing the contract and doing some temperature and pressure scanning at the same time. All those beautiful temperature scans, which are of course taken as Celsius, are sent down to Earth, from which our scientists can somehow develop new rocket parts. Mission Control has decided to spare the engineers on the ground by destroying the missile while still high in the air. Rocket parts and other trash from the explosion is naturally not cleaned up, as most of it lands in the ocean because this is 1951 and we have other stuff to do, like point missiles at each other and threaten global nuclear war. Talking about missiles, it is time to invest some research into making them more efficient by unlocking all these solid rocket engines. Having completed our first military contract and having unlocked the first material science node, we can upgrade our Hermes into the Hermes 2 to complete a suborbital return contract. The Hermes 2 features upgraded and lighter tanks made out of aluminum, increasing performance drastically. Another feature is the parachute-assisted payload replacing the previous warhead. Comparing the newer version to the older, it is apparent that the aerodynamic fins have shrunk, the fuselage has shortened a bit, and the top fins have moved further up. One thing to note with the top fins, except them moving, is that one pair has been slightly rotated into the airflow, allowing high-speed air to deflect, which slowly spins the rocket along its axis and hopefully its payload for more accurate deployment. This version is put into production at the vehicle assembly building and should be out the oven in roughly 1.5 months, including the roll-up process, which is happening in the background. Due to recent technological leaps and successful missions, the military personnel in charge of proceedings have allowed publicly broadcasted purely scientific missions to be scheduled for 1952, although most missions will still be military in nature for the foreseeable future. Skipping most of the launch, the top fins have successfully done the job in spinning the rocket, giving it a stable way up. This was mostly done to reduce the bottom fin size to save mass. Angled launch conditions mission planners had included, the chance of recovery was vastly increased, as the calculated trajectory puts the payload into the Atlantic Ocean for splashdown. Sadly, the intentional spin did not have the same effect on the payload, making the first object Europe puts into space as we cross the 140-kilometer line wobble uncontrollably. Thankfully, the scientific instruments don't care about wobble and provide us with brand new temperature readings. This will not be the last we see from space. We have put our foot in the door of the void, and its calling seems to be unresistible for scientists and warmongers alike. Mission Control is concerned with the telemetry transmitted, as it indicates the wobble might make the probe unable to withstand re-entry, as the chance it re-enters facing the wrong direction is growing by the second. Concern which proved unnecessary, as the velocity of the party hat is reduced from Mach Jesus down to subsonic speeds. Still moving incredibly quickly, some speculates if the parachute is able to open in time, as the margins have been set rather low without much simulation time going into proving its ability to slow down the payload. The parachute did its job and the craft is quickly recovered before it can sink too far into the ocean, making recovery impossible. ESRO is now the third organization to recover a sample from a suborbital trajectory. While still being behind the Americans or the Soviet Union, we are marching forward at a steady pace, not having a single launch failure yet. This influx of cash provided by the defense contract is put to use by buying more upgrades into facilities. Also, the 17 science points now accessible through extensive temperature measurements will now be used by scheduling early material science, basic rocketry, and avionic prototypes. More money will be needed to speed up the research, shown by the amount currently in development. The administration signs a contract with an unnamed Swedish weapons manufacturer to provide the said funds. Sadly, our space program cannot afford to be ethical if we want to continue doing science. Another Hermes 1 is put into production to bring the requested payload to a height of 90 kilometers. Now, to speak a bit out of character, I had tried to set up this launch by doing it before sunrise so it can be seen from space. However, I have misjudged the sunrise and the equator, and this entire launch is in night. It may be hard to see what's going on, but this doesn't really matter, as this is just another Hermes launch that is practically identical to the other two, except it's a bit heavier. This launch being done in the dark of night, so no prying eyes can even tell what might be the payload or what is going on, is conducted successfully with no incident, except someone in the mission control room forgetting to switch on the thermometer, which is noticed quite late, but we are still able to collect all the science before the missile self-destructs over the Atlantic. This successful launch is the last one for 1951, as production facilities, launchpad staff, scientists, and all other important personnel prepare for the first test of Europe's first guided medium-range ballistic missile in 1952. With the contract already being signed and required technology unlocked, the only thing stopping us are production times. This was 1951, and we hope to see you back in 1952 and beyond. And that is the end. Thank you for watching this video. This is my first KSP1 video. This is basically my first video that actually required some editing. I've been sitting on this for a while, and I'd hope to see some suggestions. If anyone actually sees this, I'm not sure anyone will, but I'm doing this for fun. This is just for fun, and hopefully in the future I can go back to this and be like, hey, this was the first episode of this, and whatever. But this has been fun. I enjoy playing KSP. I enjoy talking about it. Um I enjoy the process of spacecraft design and or like rocketry in general. And this is my outlet probably for the next few months. The next episode will probably come out within this month. The next one will not require this extensive intro I had to do. But all in all, I think this was worth it. I hope to see you next time. Um, Thank you. Thank you for watching. Goodbye.